Welcome to today's Research Pays Off. I am now going to hand it over to our speakers, Dave Johnson of Asphalt Institute and Howard Anderson of Utah DOT. Welcome.
All right, thank you very much, Lauren. Howard, go ahead and unmute yourself because we'll have you introduce yourself in just a second, if you would, please. As Lauren said, I'm Dave Johnson. I'm a senior regional engineer out of Billings, Montana with the Asphalt Institute. I have the privilege of covering 7 states from Alaska down to New Mexico. I was just looking through the folks that are here, and I see we have some Montanans, and I see Amanda up in Alaska, and I'm sure some of my other states are represented as well. But I'm thrilled that we have so much diversity of our audience today, so many different states and organizations listed. Joining me is Howard Anderson. I'll let Howard introduce himself here in just a second. He and I have been working on this technology now for a fair number of years, and I have Howard listed first in the title slide because he truly does deserve way more of the credit for the innovation and the willingness to think outside the box than myself. I've been a supporter of his efforts, and I'm thrilled to have him join me today to help communicate to the rest of you what's going on in Utah. Howard, go ahead and introduce yourself, if you would, please.
Hi, everyone. I'm Howard Anderson, and Dave, thanks for that introduction. And Dave, I've asked Dave to do most of the talking today. I'm actually preparing for another talk tomorrow this week at the Asphalt conference. Anyway, I'm here to support and help him, and we're very happy and excited to present this information and to continue to let others know what we're doing here in Utah. Thanks, Dave.
Thank you, Howard. So let's go ahead and get started. Get my controls right. So what we're going to talk about is what has happened in the past as well as elsewhere around the country, a little bit of detail as it relates to thick lift paving as well as highly modified materials. We're going to offer some insight on the first pilot project that was done at the port of entry near Wendover, Utah, just off Interstate 80 along the Nevada-Utah border. We'll talk about some of the other projects that have happened within the state of Utah, highlighting an overlay on Interstate 15, as well as a rubbleization of a concrete pavement that will be happening this year and overlaid with this material. And then we will also show you some of what's happening with some of the other states in the West, Montana, Idaho, and it occurs to me that I failed to mention, I think, Colorado on that slide, but I'll verbally tell you what's going on there as well. So I want to begin by acknowledging that this effort was really facilitated by an incredible partnership between the Utah Department of Transportation and the contracting community and the Utah Asphalt Pavement Association. Reed Ryan, who was the executive director for 12 years in Utah with their association, deserves a lot of credit as well, because of this partnership between the agency and the contracting community. The move to this material that some would have truly felt impossible has been quite seamless, and as we will see, the tonnage in the state of Utah is quite frankly exploding. So looking at some of the past experience with either highly modified or thick lifts, the state of South Carolina deserves special mention. They have been doing thicker lifts, especially along their eastern seaboard in areas where they're looking for rapid turnaround of a pavement. It may or may not be modified. It depends on the particular project, but they have had some pretty thick single lifts, almost to 8 inches, as we can see, 7.9 inches compacted. And they've consistently had very nice densities above 95%. There's very few things that happen in the asphalt world that the National Center for Asphalt Technology at Auburn University does not get involved with. And they've had a lot of experience with thick lift paving to where that now is their go-to methodology when they're looking for a rapid rebuild of some of the sections. And that all began with some work that was sponsored by South Carolina and Craton Polymers. Craton, of course, was looking at some highly modified materials. South Carolina had a combination of the two. The Craton material in particular was laid in multiple lifts to a total of 5.75 inches, so 5 3/4 inches. It was a 12.5 millimeter mix. They also got fantastic densities. And in fact, while it's not listed here, we say great performance. It was truly acting in a perpetual fashion. Unfortunately, that section was not re-sponsored by Kraton, and so it was removed after one cycle, 20 million easels. But very encouraging that we could have perpetual performance from a pavement, say that 3 times real fast, that was surprisingly thin, so less than 6 inches in thickness. Utah began work on this back in about 2015. They were doing a lot of work with the Hamburg device. Utah was one of the pioneering states of the introduction of that work machine into the United States. And so they did a lot of Hamburg work. We've got some test results that we'll show you in just a moment. These were a typical 12.5 millimeter super paved mix. They had binder samples from a various asphalt contents all the way up to nearly 7%. They were running 40,000 passes, which is, as many of you know, double the pass count, even for a higher pass count, typically with the Hamburg. And as we'll see, they were making some modifications to the equipment for the second 20,000 passes. They did a simple substitution on a couple of projects that were constructed in 2017. Well, the simple substitution was taking a super pave mix design that had been designed with a, I believe, a 64-34 binder, and they simply dropped in a 76-34 binder and laid it at typical lift thicknesses of around 2 inches. The performance on that has been very acceptable, but Howard recognized that we could get more out of this mix if we were willing to look outside of our normal box of volumetrics. I said that they made some changes to the Hamburg. You'll notice the duct tape extra weight. So they ran the Hamburg at its standard process for 20,000 cycles, and then they increased the weight for the second 20,000 cycles. You can see the results with, in the blue, the original 20,000 passes, and then in the orange, the additional 20,000 with the extra 20 pounds. And so 158 pounds is your normal loading, and the second set was with 178 pounds. The other thing that we want to point out is the air voids. So you can see we said it was multiple asphalt contents. They are showing here the results at 1% increments starting at 4.8% up to the 6.8 peak. And notice that the air voids underneath the wheel went from a little above 7% at that lower asphalt content all the way down to the lowest value in the far right of about 2.5% on the, excuse me, about 2% underneath the wheel on the 6.8 low air void count. So the other thing to notice is 10 millimeters is the rut criteria for Utah on their typical Hamburg at 20,000 passes. Even after 40,000 passes, the worst performer was still meeting that requirement at just under 9 millimeters of rut. Here's what those slabs looked like just visually so you can see. Anyone who's seen, and these were cut from directly under the wheel. And so there's not a lot of distortion that we see there. To help put this in perspective, Howard and his crew have produced a couple of different videos. We're going to begin with one that is showing what happens in relationship to rutting. And Howard does a great job of thinking outside the box as well, and looking at some of the things that relate to common everyday experiences and how they might relate to a situation that we as pavement engineers converse in. And he wanted to look at what would 1 kilopascal of pressure relate to in real world terms. And in his spare time, he did some math and he found out that that would be about the equivalent of 11 stacked dimes. And so with those 11 stacked dimes, he placed them on top of a couple of different samples. And we have a video that they produced that will help to demonstrate this. So I'm going to let the video play and quit talking for a second. Notice that this is a time lapse.
I don't see the video playing on mine.
Oh, you don't? Shoot, I
I'm
can see it
seeing
just.
it.
Okay,
So
thank you. So here we are a little over 1 day in. And I'll have a couple of still pictures that we'll talk through in a moment. But look, at very little's happening now after we get through that initial distortion of the material. So visually, they let this sit at room temperature, so right around that 77-degree mark that is so common in asphalt. And notice that at some point we wound up not seeing a lot of progression. But the dimes in the 58-28 on the far left have been completely swallowed up. The 64 34 and the 70 28, we can still see those dies, but they've made notable penetration into the binder. And then finally the 76 34, while yes, there was a little bit of a distortion, it's quite minimal. Thought I had another picture. So there's 7 days, there's 14 days. And we have another video. So they just recently, and quite frankly, I just added this video this morning. They did some more lab goofiness. When you have an asphalt lab, you come up with some really neat ideas. I remember when I was at Montana State University and in charge of our asphalt lab there, we would play around with some different things, and Howard and his crew have done so as well. And they wanted to look at these materials, the same 4 binders as we just saw, under the elastic recovery device. And then they took it one step further, which is really interesting. And I'm not sure who may have any experience quite like this one, where they put it at low temperature, as we'll see, just a little bit, ever so slightly below 0 on the Fahrenheit scale. And then they dropped their specimens from a 3-foot level.
And I would add, Dave, that these beams that are dropped have been through the rolling thin film oven and the PAV, just like a normal BBR beam. And then
Perfect.
also you'll be able to see how they pour out, which is really a requirement for this to work, that they all are able to pour and mix at the higher temperature. But go ahead and play it.
So we have it playing, and we just poured the specimens, and here we are stretching it on the elastic recovery device. So the dog bones are getting pulled out, and then they were trimmed, offering some of the commentary because I don't think Howard can see the video again.
I'm able to see it now. I had to press play.
Excellent. And then we will be moving to the low temperature now, and there's all of them being dropped in a single frame, but here they are in slow motion, one at a time, starting with the 58-28. So that's again a 36-inch 3-foot drop getting pushed off a countertop. 64-34, so we went from unmodified to a modified, and a 70-28, and all of those first 3 shattered to some extent. But notice on the 76-34, yeah, there's one little chip that came off, but the beam remained essentially intact. Anything else, Howard, you want to say about that before we move on?
No, I mean, just to emphasize that a 58-28 looks like it's going to be the best for cracking because it looks so soft, but actually it's the worst. And you can see that in the elastic recovery. We could see it in the M values, but a picture is worth 1,000 words, and showing a video of it, it makes it a lot easier for people to see the difference. That just the high mod is stronger. It's not brittle.
Yeah, it shrugged it off, much like it's doing out in the field in the various installation locations. For those who might be interested in the Utah spec, you'll notice that it's very heavily aligned with the AASHTO M320 spec. Howard, would you point out any changes that you've altered from the 320?
Yes, we have the G star spelled out separately from the phase angle, and the G star is put at 1.3 to make sure we're in a good position there. And we also have the elastic recovery at 90% minimum. We do cut the sample immediately within 2 seconds. So this 90 minimum here would represent about an 85 if you follow the AASHTO procedure. And then we've got the delta TC parameter added. That's with only 1 pressure aging vessel. because that's what our industry was asking us to do. And that's why that number is moved from -5 up to -1. Other than that, it's pretty much an M320 specification.
Yep. And I'll just add the binder suppliers in Utah have done a tremendous job of figuring out how to properly formulate. One of the issues and that they were faced with was overcoming difficulty of this material pumping through the field facilities at the hot plant. And they each have come up with a means of doing that. It's not necessarily the same process and technology for each of them. But the bottom line is I think we have 4 approved suppliers, maybe 5 now in Utah. So
Yeah, 4. And like you said, they are using, instead of a 2-inch line, a 4-inch line. And they have figured their formulations so that they have at least a 2-week shelf life. And some of them don't seem to have a shelf life. And that's a critical thing, that you still keep your rotational viscosity in there, and to make sure that it is pumpable and doesn't continue to gel.
Absolutely. One of the initial projects with the drop-in back in 2017, that project did experience some difficulties in the field of moving that material through the plant. And so some changes were made and things have been working out quite well. So this moves us to the initial pilot project that occurred near Wendover. As we can see, this is right along the Nevada border. This location is most famous worldwide for the Bonneville Salt Flats, where world record land speeds are attempted and commonly broken. It is a extremely high truck traffic area with between 2 and 2.5 million easels per year, with about 51% of the traffic stream being heavy commercial vehicles. It does get quite hot in the summer. And just for your information, I wanted to show you that if we were to use the standard LT-PP bind software at a 98% reliability, the binder that would be specified would be, in fact, a 64 minus 28. But we're using a 76 28, so we've got 2 bumps on the upper end and 1 dump on the lower end to get to that.
The 7634.
It's the 7634. Did I say something different?
You said 7628.
Thank you for that correction. All right. And the project itself was a 6-inch single lift. They milled and inlaid some existing Portland cement concrete, around 330 tons, highly modified binder, of course. It was a dense graded 12.5 millimeter super paved mix, and we'll show you that mix design here in a moment. It was constructed in a single lift, and it's also noteworthy that this is a 2-hour one-way haul. So they were producing this material just north of Salt Lake City. The contractor was Staker Parsons, part of the CRH group, and they hauled it over to the Nevada border along Interstate 80, which takes them roughly 2 hours. You can see the mix design requirements calling for that 64-34 binder. Normally, this would have been a 75 gyration mix design, but as we see, they dropped that down to 50. As mentioned, it is a 12.5 millimeter nominal maximum aggregate size. This is a hard rock quarry. It's 100% crushed material. The binder minimum requirement is 6%, which is exactly where this mix was designed to. The air void, the range now is 0.75 to 1.25% air voids. 1% was what this was designed at. And just FYI, if it was taken out to 75 gyrations, it would essentially be a 0 air void mix. The allowable range for VMA, as we can see, is 15 to 17. They were towards the lower end of that at 15.3. With those other volumetric changes, that requires a change in the VFA. The range, as we see there, is 90 to 95. This one came towards the middle of that at 93.3. They did a drain down test with that higher asphalt content. They want to make sure that there wasn't going to be issues. Normally, you wouldn't do this in a super pave mix, of course. We would use that for SMAs or an open graded friction course and that type of technology. But as we see, drain down wasn't an issue. RAP is allowed at a maximum of 15%. That equates to about 12.5% binder replacement. And the contractor hit exactly 15%. And then you can see the Hamburg results for this mix after 20,000 passes. And there was an adjustment made. We talked about in the initial work how they had added weight to the Hamburg. Now, instead of adding weight, they changed the temperature, bumping it up 4 degrees centigrade. And the other thing that's worth noting is normally with your Hamburg and other performance tests, you typically target a 7% air void value on those specimens. Because they were designing to lower air voids and going to be requiring a minimum of 96% density in the field, the decision was made to also make an adjustment to the Hamburg slabs. And we can see that that target was 4%. As an aside, I can tell you that the first specimens that were made by Staker Parsons were at the more normal 7% value. They also ran them on the Hamburg, and they did not fail that 10 millimeter criteria. But as we can see here, after 40,000 passes designed and built at 4% air voids and increasing that temperature by 4 degrees on the second 20,000, they had a grand total of only 6.1 millimeters of rutting.
So
this is what a specimen. Go ahead.
Dave, I was going to add that our specification has evolved on the Hamburg to where we just, because the rutting has been found to be no issue, that we are just running one 20,000 cycle Hamburg test at 54 Celsius.
That's right. Thank you for that addition. So just FYI, these are what the specimens look like. This is a 6%. This is that initial project. Yeah, they appear a little bit rich, but there's nothing really terribly extraordinary about the pills. A little bit more detail on the Hamburg. We already saw a number of these, and I mentioned how we made an adjustment to the air void content. There was that shift in the water bath temperature, the standard wheel loading at 158 pounds, and again, a total of just over 6 millimeters after the full 40,000 passes. For those who've seen Hamburg graphs, these are the two 20,000 passes. Notice how linear these graphs are. There is certainly no stripping inflection point. Very rich low air void mixes are not likely to have issues with stripping, and that is not a surprise that we don't see that stripping inflection point, but it is a extremely stable mix under the Hamburg. Staker Parsons, as was mentioned, is the contractor for this initial project. They were producing this mix just north of Salt Lake City at their Beck Street facility, and they wanted to verify that they could actually work with this material and get the proper density. And so they made the decision to produce mix and lay it. They were not compensated financially from the Utah Department of Transportation for this part. Notable differences, as we mentioned, we're going to be paving essentially in a bathtub out at Wendover, surrounding the mix by Portland concrete cement in that milled area. Here, it's truly an unprepared aggregate base. That's their scale that we see in the background. A lot of trucks through the years have gone through there. It is very, very well compacted, but their preparation was simply to run a blade across it and then broom it and then pave it. There is no haul on this, so instead of that 2-hour haul, it's virtually a 0-minute haul. The test strip construction went without much of a hitch. Compaction was done with the single double drum vibratory roller, as we see in this picture. Just an example of what it might have looked like after an initial pass. I have to say that my one regret is I don't have any pictures of the roller hanging off the edge of this mix. We all expected it to walk out a little bit. It was shockingly stable. Not too much of a surprise when you're trying to pave at this thickness. The volume of material that's running through a paver is pretty exceptional, and the contractor did have to make some adjustments to their process to make sure that they adequately fed the paver. Of the various things that they looked at in this test strip, this is one of the more valuable pieces of information. Temperature is 275 at the surface and just at about 300 internally, so not exceptionally warm. What did we learn on the test strip? That achieving densities of over 97% was rather easily done. Regular rolling equipment and procedures were followed. The roller operator for Staker Parsons, she and I chatted quite a bit, and she had anticipated trying to just simply use her normal rolling pattern, and she was willing to make adjustments if that proved to be necessary. But her normal rolling pattern was functioning just fine. Feeding and placing those large volumes was achieved, but as we saw in that picture, there were some challenges associated with that. The mix was exceedingly stable. There really were no significant issues encountered in the production of that test strip. So with the confidence gained there, they headed out to the Wendover facility the next day. This is looking back towards the state of Nevada, just off of the interstate. I-80, that was the forward end before the scale, and here we are after the scale. I will point out, as anyone who knows me very well realizes, I'm a big proponent of good tack coat. I'm sure that Staker Parsons is doing a better job with those now than what they did in this particular one. But a couple of things that I also would like to point out is notice the size of this windrow. So they are using a material transfer vehicle. The contractor had redundancy out on this project. They did not want to be hampered because of any sort of equipment breakdowns. And the feeding of issues that they saw at the Beck Street facility were pretty well handled by the time they got out to the Wendover project. But a very, very large windrow. Quite frankly, you wouldn't really be able to go any wider than this and put down more material than what they did on this effort. Feeding, again, issues had been overcome. Again, single roller, they have the redundancy there. The internal temperature with that 2-hour haul was about a 25-degree drop, so that placement was right at about 275 degrees. There was a temperature probe that was placed at the bottom of this, which is still active. You can still plug into it and get temperatures if you would like. But notice the long duration that it's taking this material to cool off. Thermodynamically, that truly is not a surprise. You have an incredible volume of material, and the cooling curves are very, very long because of that volume. Plus, this was done in July, hot temperatures. Air temperatures were going above 90 degrees at this time, fairly long days. And so it took quite a while for this material to cool off. On the positive side, because it takes that long, there is the potential to extend paving seasons, as well as the window of opportunity to get density is very wide as well. What kind of densities did they get? Well, Utah is a percent within limits state, and they did apply PWL calculations to the cores, but only the top half of those cores. And so they popped a total of 4 cores and cut those cores in half, and then measured the density both top and bottom. And the densities in the top half were very, very consistent. We see the ranges between 97.2 up to 97.9. In the bottom half, we generally had some very good densities as well. But notice on core 2, and in particular core 3, that there was a bit of a drop off. What had happened there is that there was an issue with the delivery in terms of there was a truck that had broke down, which then meant that there was mix sitting in one of the shuttle buggies, which then had some issues getting that material out. They had the second shuttle buggy on site, but the upshot is that there was an extensive delay in the process because of that one hiccup on that one truck. And the result was that in the bottom half, the density was still pretty respectable at almost 93%, but 92.8 was a notable low spot. So how has it gone? Well, what we learned is that highly modified asphalt can be successfully constructed even with a 2-hour haul. And this has been something that has come into play with projects since 2021 when this was built, where they do have some longer hauls with some of this material. High densities, as we saw, were easily achieved. So far, this particular location has seen over 5 million commercial trucks, and quite frankly, there's nothing wrong with it. There's no discernible movement, absolutely no cracking, and zero distresses that could be of note. The question that I get asked, is there any rutting? And I say, oh, absolutely, there's rutting. It might be 2 millimeters. It's very, very minimal. So this is what the test section looked 5 months afterwards. And then I was out there in October of 23. And again, the section looks fantastic. All that cracking you see in the foreground, that is not this material. The material is only on the scale area. And the thing I want to point out, especially in this picture on the right, is notice that extremely long queue of trucks. Quite frankly, the trucks were queued all the way back to Interstate 80. They could not put any more trucks in this queue than what we see there. And this is not abnormal conditions for this site. So recognize that you have a significant number of trucks. They are going to be at a standstill for much of their time on this material. When they're not standing still, they're moving at very slow speeds. Absolute recipe for rutting, especially in these hot conditions. And despite all that, the mix is standing up extremely well, and no rutting of any magnitude has been experienced.
So Dave, let me add a comment. If you want to go back to that slide, the Lonnie tried SMA in this place, and it lasted 6 months. and it shoved, and they had to remove it. So for this to work under these loading conditions, Lonnie's comment was, if it works here, it will work anywhere. And the other thing is that there has been no movement of the binder within the mix. There's absolutely no flushing. And the 2 millimeters or an eighth of an inch rutting that you mentioned is from wear of all those trucks going on. I mean, it's just worn the surface a little bit.
Yeah, and I'm glad that you mentioned Lonnie, because the selection of this site was done purposefully by Lonnie, because as Howard mentioned, he figured if it works here, it'll work anywhere. And quite honestly, and Lonnie is free to admit this and does so, he did not expect this to succeed. And he had money in the budget for this project, anticipating that they were going to need to remove and replace it in relatively short order. And as we'll see, we talk about how his opinion of this material has become probably the number 2 champion in the state of Utah behind Howard for it. Questions come up about safety, of course, and skid numbers at a truck weigh station. That's less of an issue than what we would have in terms of a more normal operation. But they did do some British pendulum testing of the existing material and then that new pavement, and notice that the values of that new pavement were very acceptable. Those values typically are going to go up a little bit in time as we remove some of the binder from that rock, and then they tend to stabilize. So 53 on that new pavement is very, very good. Cost considerations, that first project cost $150 a ton, and I've got a little table showing you in a moment what has happened with this material in terms of cost through time. The expectation was that it was going to end up similar to an SMA, perhaps be slightly less, and we'll see how that has worked out. We expected the binder content to be less than what was required for an SMA, but because of that high polymer, thought it would be a bit more expensive. We didn't anticipate the need for anything like mineral fillers or fibers. We figured that the testing would be slightly less for both QC and QA than what it was for SMAs. We thought that we could produce this at a higher volume, and we did expect that with time, the cost of the polymer would become more cost competitive as it moved to be more of an everyday mix in the state of Utah. The contractors also really appreciate the one lift paving. They have a large window for compaction, and it gives them the opportunity to get good densities without working excessively hard. We have less cost for traffic control, because the turnaround of a project can be that much quicker. User costs therefore get reduced. It's also noteworthy that with that single lift paving, we don't have an opportunity for a debonding between layers, because there are no layers other than that single lift, and therefore we don't need tack coat glue between those layers. This helps to produce a stronger, more durable pavement. Work that's been done both at TTI and NCAT helps support that statement. We really also, as I mentioned before, see a potential of expanding the paving season, both early, maybe not quite like we have today in Montana at 0 degrees Fahrenheit, but early season and late season paving windows can be expanded because of thick lift paving and the cooling rates that are extended under those designs. Maintenance of traffic, it does take longer for this to cool off, and especially where you have heavy truck traffic, that should be considered in when you choose to reopen this material. The question on IRI, we'll get to that in just a second, because you're alluding to a potential negative with thick lift paving. Smoothness, with one less opportunity to improve ride, there is generally going to be a greater challenge in getting that smoothness, especially with a thick lift paving. Any little mistake that the paving operation makes is going to be magnified with that thick lift. So you asked about the IRI at the Wendover facility, and quite frankly, it is a little bit high, but because of the speeds, it's not an issue. There's plenty of information about these more mainline projects, and what Utah has done is lay this material down, profile it, and then do smoothness grinding, bump grinding, if you will, to get to the required smoothness. We'll also see in a slide here in just a moment that this high density material its grinding operations go very, very well, quite similar to what you might see on a concrete pavement, actually. There was a desire to see how this material would perform in some other severe conditions, and there was an opportunity on Interstate 15, fairly close to the production facility. If you're familiar with Salt Lake City and you're north there, and there's an amusement park at Lagoon, that's roughly where this material went down in the northbound lanes of Interstate 15. It was a concrete pavement that had, quite frankly, performed as we would hope. It had given adequate service to the Utah DOT, but it was time to consider a change to that material. It had reached the end of its life. The plan had been to, I believe, to crack and seat this material. And the decision was made, let's place some of this highly modified low air void material on it in a single 3-inch lift, and let's see how its performance is. And so that's indeed what was done. It was the same contractor with the same mix design, and so the same unit cost, and they laid that down in 2021, I believe, and that material has held up very well. It got very good densities once more at about 97%. The binder content was really, really close to the design of 6%, and the VMA was a bit higher than the mixed design. If you recall, that was 15.3 at 15.7. Performance has been extremely good. I will say that from my perspective, I'll add, unfortunately, they overlaid it with an SMA this past season that had been planned. But the problem with that, from my perspective, is we no longer have a visual perspective on the pavement. It was doing very well. There was no cracking to be noted, and we expect that it will continue to perform quite well. Here's some shots of that material at the beginning of that project, moving through it, and one more just for good measure. Very good performance. This is about a year after it was installed. There's been a number of other projects that happened between 21 and 23. Those are all listed here. We'll note that thicknesses ranged from a low of 1.5 inches, an inch and a half. Some of those 1.5 inch overlays are on bridge decks in the thickness of 6 inches at the peak, and anywhere from 96, a bit over 96 to a bit over 97% has been the density on these projects. I apologize for the size of this, but these are more installations that are happening in 25, as well as some that happened last year. We'll talk a little bit more detail about a couple of those. Those are the two red ones. Just to show you how acceptance and growth of this material has occurred in the state of Utah. That first project was that 330 tons that was placed at the Wendover facility at $150 a ton. In 2022, there was an increase of tonnage of about a 9-fold increase to 3,000 tons, again at that same unit cost. Then in 2023, there was another 8-fold increase, a bit over 24,000 tons in some different applications. And we saw that the cost per ton went down as the industry became more comfortable with this. The price went down, as well as that higher volume of material. The one asphalt producer in particular was very aggressive in their pricing to attempt to be successful on those projects with their contractor colleagues. Then last year, things really started to explode. And Howard was just telling me before this webinar began that 525,000 tonnage was actually not achieved last year. Some of those projects are carrying over until this year, but there was still a notable increase. Howard, that was almost 400,000 tons. Is that what you had said happened in 24?
Yes, I don't have the number right in front of me, but it was maybe around 350,000 tons that was completed. But we had a few jobs that were scheduled as SMA, and our contractors asked us to change order those or to allow them to substitute the high mod instead, because they like the high mod better because it gives them the regular dense graded aggregates, and it's more sustainable for their pits. So we allowed some of those change orders to happen. We don't think we tracked those in our database properly.
Okay.
So we're trying to figure that out. And then the other reason for the increase in this price that you see at 152, we did 19 bridge decks out by the airport, and bridge decks are more expensive to install. And then we also had a very large project down in our southern part of our state that we were opening up that did not have a pit. And so we knew we would have higher prices down there, and so that kind of skewed the price up. But in reality, we expect our prices to be around the $125 a ton number instead of some of these. I'm just giving you an explanation why that number showed higher.
Excellent. Thank you, Howard. We did some testing at the Asphalt Institute lab, some beam fatigue testing, and I really want to focus in on the two boxes that are highlighted in red. Notice that we were using a 64-34 super pave mix, comparing it to the highly modified mix. Also want to point out that the super pave mix was targeted at a 7% for those beams, and much like Howard in Utah has done with the Hamburg testing, we targeted 4%. And look at the incredible difference in the performance, somewhere around a 70-fold change in the number of cycles to failure at these respective microstrain rates. So significantly different material is the upshot, because that 64-34 material has performed very, very well. And it is a proven commodity in the state of Utah. And this 76-34 binder, low air void mixes are blowing it away. We have some additional independent testing. The mobile testing lab for federal highways was in Wyoming doing a project. And so we delivered some of the 64-34 super pave binder as well as highly modified binder. This material is currently getting tested under the Texas overlay test. I haven't seen any of those results yet, but we should see them soon. UDOT out of the Corps of Engineers out of Vicksburg collected material last summer, and they are planning on testing it. We don't have information yet on what exactly it is that they plan on doing with this material, but I'm reaching out to Dr. Ben Cox to get those details. And then we have others that are wanting material to test. So for example, Tom Bennett at Rutgers University has asked for material, and we are hoping to get him some material. Dr. Ahmad Kasim out of the University of Idaho, he also is interested in getting some material. And so I offer that to say, stay tuned. We expect to get more independent testing with some unknown testing regimes at this point, but we are looking forward to being able to report on those when they become available. So what lessons have we learned as a state and as an industry? That with this material, getting densities above 96% is very easily achieved. That helps to facilitate a rut-free pavement. Regular rolling equipment and procedures have been followed very successfully. Feeding and placing of large volumes of mix was achieved. It does require diligent planning on the part of the contractor, but when they properly plan for that, having enough trucks and cycling properly, they've been able to maintain good, smooth, steady flow of material. The mix is very stable and workable. Thin lifts as thin as 1.5 inches have been placed successfully as well, and it's working quite well on bridge decks, as was already mentioned. Howard talked about the flushing issue. The details of this slide are more than what is necessary. The bottom line is he did some calculations to verify that even at those low air void volumes, that there would be enough room. So in the expansion of this material in the heat of the summer, we would not experience flushing. And the upshot is that there was adequate room, and we indeed have not seen flushing in the field. Some notable facts. We have seen a huge increase in the tonnage. About a 20-fold increase was planned in 24. As we already mentioned, some of that is carrying over to 25. That is looking at what had happened in years 21, 2, and 3 compared to 24. Average bid prices are typically falling between super pave and SMA. And as Howard mentioned, the contractors are very encouraged and supportive of this mixture. They are offering value engineering proposals to the state of Utah, which are commonly accepted, switching SMA projects to this material. It's also worth noting. Go ahead, Howard.
Dave, I was going to add that they're giving us money back even when they're change ordering. So
$7 to $8 a ton, I believe, is the number I've heard.
Yes, yes, and and even at that point, they're very happy to do it. So it's last year we did more high mod mix than any other single. We did more high mod than we did regular HMA or SMA last year.
Yeah, it definitely has become the go-to mix. And in 25, 90% of the tonnage in Region 2, which is the Salt Lake City area over to Wendover, is going to be this highly modified low air void mixes. An advocate whose name might have the initials LM, who decided on the first placement for PCC, is now flipping Portland cement concrete projects. And we have one in particular in Region 2 on Interstate 15 that I'll give you some details over. So far, performance has been exceptional. We haven't had any issues on any of the installations in the various configurations to report thus far. Is it a perfect mix? No. Will we have a problem at some point? I think the answer is yes. But as long as we are doing our due diligence and getting a good mix design with good construction technique, it's going to be hard pressed to actually have a notable issue. So here's some details on that Interstate 215 reconstruction. Excuse me. This was originally designed to be a removal and replacement of the Portland cement material that was there. Because of the excellent performance, the question was asked, should we look at another option? And they wisely pursued an evaluation of rubbleizing the existing material and then overlaying a total of 5.5 inches of the highly modified low air void mix. They're going to rubbleize it this year and do an initial leveling course of 1.5 inches and then a final lift of 4 inches. That's going to equate to a $40 million savings compared to the original remove and replace option. What are they doing with that money, you might ask? They're extending the project 17 miles for additional ramp reconstruction. So they're going to do all the work that's necessary, within the boundaries of the original project, and then take and steward that extra $40 million for 17 more miles of ramp work. So a tremendous cost savings on the project, and then good utilization of that money further down the corridor. We do have some future projects. I didn't think I had Colorado, but there it is. Montana, and I know we have some of our Montana engineers on who are partners with NRRA. They released a bid last fall for 19th Street in Bozeman. Much of what they're doing specification-wise is emulating what is going on in Utah. Montana is a massacre state, and still, instead of the 76-34 binder, it's a 64E-34 under the massacre system. I do know that suppliers for both states, Idaho Asphalt in particular, that was the supplier for that first project, they are actually utilizing that exact same formulation for the 76-34 and sent that to Montana to compete for the 64E. Instead of a 12.5 millimeter mix, it's a 3/8 inch mix, a 9.5 millimeter mix. The project was awarded and it was about 75% less than the engineer's estimate, and that will get constructed this year. The Idaho Department of Transportation Department, they as well have been watching this mix, and they have identified a project. It's going to be a 12.5 millimeter mix emulating the Utah spec. They might be raising the air void slightly. They're talking about doing a 2 or perhaps 2.5% air void instead of the 1%. And they also are looking at the 25 year for their construction. Colorado has been searching for a project. They are looking in the northwest region of Colorado. They're planning on emulating the Utah spec. They're hoping to get that built this year as well. My last communications with them is that they had yet to locate the project. They had a couple of candidates that they had narrowed it down to, but the final selection, the last I heard, had yet to be made. So with that, I want to thank the Asphalt Institute members, all 129 of them. It is their support that allows me to be a part of this. It's their support that allows me to help get the good word out on the fantastic work that Howard and the Utah DOT is doing with that. And so with that, I will be happy to take any questions. If you want my contact information, just scan that QR code and you will be able to throw that in your contacts. Howard, anything you want to add before we jump into any of the questions?
Sure. I'd add the comment that we've heard from our contractors that the the high mod has been going through their pavers very well with less clean out effort than the SMA was. So
Okay.
that's just an added positive. They've also told me that the mix designs have come in very well. Another thing that I've thought about is that we talk about film thickness on our aggregates as a leading potential on how durable the material is going to be. So if you think about SMA and the high mod, they both have approximately the same binder content, but in the SMA we have a higher 200, and we also have mineral fines that we're adding to the mix. So we have a mastic that's taking up a lot of the surface area of the binder. So I believe that the film thickness of the high mod is more than what we had with the SMA, and also because we have the 7634 binder itself is stickier and would tend to give us a thicker film. So I think that's going to also benefit us in the durability part of it. And then if you look at how we aged the binders with the rolling thin film oven and the PAV, that was estimated to give 5 to 10 years of service life for the aging with the binder. And I believe that's probably modeled to a pavement that has 7% air voids. So for a high mod mixture that's compacted and laid at low voids at 4%, that predicted performance for PAV aging of the binder, I think, is more than the 5 to 10 years now with the high mod, and possibly 10 years or a little more than that. Just a comment.
All right, and I appreciate those comments, and we do have some questions in the chat. We have a question about the Hamburg wheel tracking temperature. What's your opinion about the temperature, a constant 50 degrees C regardless of the PG grade? And in our western states, historically, we have had adjustments. So Colorado, Utah, and Montana have all adjusted their Hamburg temperatures relative to the high PG grading. There's different ways that states approach that, and we could have a significant conversation around temperatures. Some states keep that constant temperature, but will make adjustments to the wheel passes, excuse me. Others will make adjustments to those temperatures, and there's some other approaches that people take. Arguments for and against different temperatures and different passes could be made. My recommendation is to devise a system that works well for you and your state, and then move forward with it. It is, I will mention, one of the challenges that Montana has experienced with that move from PG to massacre, because they used to make adjustments to that upper PG based on that upper PG value, and they now are a constant upper value in the massacre system. We have some questions related to the aggregate, Howard. I don't know if you can see Adrian's questions about LA wear absorption. I don't know those answers personally. Do you have that information?
I'm trying to find the question, but we have the same aggregate specifications for our highly modified mixes with our regular mix. So the LA would be the same.
Do you know what their absorption is out of the back street?
I don't. I think it's certainly around 1% or less.
And then there was, so fairly low.
Yeah.
The other question that is offered is, what is the original plan for the decks? And I'm not sure if there's more to add than what you already had mentioned, Howard.
For the bridge decks?
Yes.
So what we're really happy about is that the bridge decks are compacting to 97% density without the vibration. And so we've never had such good compaction on bridge decks before. And that has been one of the places where we've had issues with potholes.
Okay, excellent. Mihai, great to hear from you. The question is, what type of polymer and what percent? As you may not be too surprised to hear, the suppliers are being relatively tight-lipped about their formulations. They see a need for competitive advantage. I will say what I have heard is it's around 5% of an SBS polymer. I know that they're utilizing some different polymer systems from different suppliers, but around 5% is the loading that I'm hearing. Brandon, the question is, thank you that you think it was a good presentation. I appreciate that. Any thoughts on pavement life increase versus conventional mixes? Well, I'd point you back to the results of the beam fatigue testing. And I'm not going to claim that there's a one-to-one relationship there, but I will just point out that the incredible difference between the results of the materials under the various loading configurations on the beam fatigue certainly support the idea that we're going to get notably longer life out of this material. The oldest installations are now approaching 4 years with the low air void high mod, and so we don't have a long history with it in the field to be able to come up with some of the predictions on the life. But as we already mentioned, we don't have any distress that has showed up yet at any of the installations. The lab work that we've seen thus far has been fantastic. And so the upshot is we're expecting very, very good long-term performance with this. Again, we've got extra testing that's going to be happening in different locations. I mentioned the Federal Highway and the Corps of Engineers testing that's going to occur. And as we get more of those results, we'll have a better feel for how this performs under diverse lab testing conditions. And therefore, we can also have greater comfort in saying what we think will be happening in terms of the field performance. I'll jump. Go ahead.
Dave, I'd like to add also that we know from studies that an increase in density of 1% is usually an increase in pavement life of 10%. And so a lot of those studies, maybe they don't go on the low side of the density where we're at, but we have every indication with the film thickness and the densities that we are increasing the life quite a bit. And that's why I would like to stress, in my opinion, the importance of staying with a low void design, because that's how you can get the higher density compactions. Will this mix work at a 2% void design? Yes, but you may not have the 97, 98% field compactions that you can get if you go to a low void design.
Agreed. And just skipping one question for the moment, Maxwell was asking about cracking performance. I know that we've done a fair number of ideal CT tests within Utah, and recall that we will be getting some Texas overlay tests from Federal Highways, Maxwell, which we don't have those results. Howard, would you want to mention a little bit about the ideal CT results that you've seen?
Yes, we're getting numbers similar to what we see with SMA, around 500 to 1,000. So we're not sure what that means when the numbers are that high, but it's indicative largely on the higher binder contents give us a very good ideal CT test result.
All right, excellent. And the last question that we have in the chat, which is probably the last one we have time for as well. We are a couple minutes over already. I seen Lauren shaking her head yes. How well does it hold up to salt and frost heaves at the very low air void, high film thickness? I don't anticipate any issues with salt. We haven't seen any negative results there. Frost heaves, haven't heard of any issues related to that as well. Howard, do you want to add in anything on that?
We try to stay away from any issues with frost heave by having our pavement up high enough and in the proper slopes and enough gravel underneath it. So we certainly don't want any water underneath this mix, because it's going to be harder for water to come up through it.
Yeah, absolutely. Properly designing your base materials so that they'll get good drainage minimizes any opportunity for frost problems in the first place, regardless of what's on top of it. So I realize that we've gone a couple of minutes long. I'll turn it back over to you, Lauren. Thank you, everyone.
Yeah, sounds good. Did you want to answer the last question that came up from John?
Oh, let's see. SMA, was that placed at 6 inches? I don't know that answer. My guess is probably not.
It was not. It was placed at the normal 1.5 to 2 inches thick.
Thank you. Okay.
Great.
And Michael, you're very welcome. Thank you for inviting us.
Yes, thank you so much. I will just wrap it up here quickly. Thanks for joining us. We'll get this recording up by the end of the week, and you can share this out to anyone else that might have not been able to attend today. Everyone stay warm and stay safe with whatever weather you're experiencing right now, whether it's another foot of snow like in Montana or minus 12 degrees like here in Minnesota. And we will hopefully see you next month. Thank you.
Thank you so much. And if anybody wants a copy of the presentation, just get a hold of me and I'll send you a PDF.
Thank you.
Great. Thanks so much.
Have a great day, everyone.
Bye.